A very good morning to everyone and welcome to day 3, the concluding day of the 3-day workshop on statistics in data science and machine learning. Today's session we will dive deeper into neural networks, advanced analytics and multivariate statistics. To begin with, the first session we have is the evolution of neural networks in the age of AI. This session will be presented by Dr. Deepak A.S. He is the Associate Professor of Analytics, PMI, Manipal Academy of Higher Education, Bengaluru. Dr. Deepak specializes in business analytics, data-driven decision making. His expertise spans across AI models, neural networks, and predictive analytics. I request you all to kindly welcome Dr. Deepak. I request Dr. Jyoti AB to welcome Dr. Deepak with the floor. Please, Dr. Please. Thank you, everyone. Over to you, sir. You can start the session.
Thank you. Good morning, everyone. Morning, sir. I'm not an outsider. I've been here for 30 years, but we have not been here for the past 1 year. So, which semester did you guys belong to? I think I perhaps seen you in the first year. So, have you taken up any course in machine learning? Have you taken? Have you studied neural networks? That's good. So this talk is about a very brief historical overview of neural networks, how it has developed, starting with the Rosenblatt single perceptron model up to GenAI. But of course, I'm not going to too much in details of all the historical facts, but just an overview of that. And most importantly, I would like to introduce you to at least one simple application of neural networks, which is CNN, and we'll see how we can use that to classify hundreds of applications. So that is one of the very, very simplest examples. That's what you can build this. So if you have any questions in the middle, don't hesitate to stop and ask. Right? We can stop for question and answers and discussions at the end. But still, if you have any immediate questions on this. So after Ramaiah, now I've joined TFI Management Institute, which is part of Manipal Academy of Higher Education. So I've been there for about 2 years now. So this is the overview of the talk. So first we'll talk about what is this neural network and especially what is this neuron, right? And early history of the neural networks, or basically the single perceptron model that we have. And then basics of this neural network, which is the feed forward and the back propagation techniques. And then we'll go into deep learning, modern deep learning, and a little bit about this Gen AI, and we'll look at one practical example. So this neural network is basically motivated by how our human nervous system is organized. So if you look at a unit of this nervous system, which is a neuron, right? So if you look at the biology of the neuron, so it has got this nucleus, which contains or which is connected to these dendrites, right, followed by axon, right? And then, so all these dendrites are sort of like connectors which connect to other. So basically, in our nervous system, then all the neurons are connected to the other neurons. The only thing is, when some signals has to be sent, certain neurons are fired and certain other neurons are stopped. And the same concept is being used here in neural network. So now if you look at this neuron, which is sort of an approximation of this biological neuron that we have. So we have multiple signals that are coming into this neuron. Now what happens here is that we multiply these input signals with the weights and bias. Okay. And then we take the summation of this and then we pass that to the activation. Okay. So depending upon the strength of these signals, so and this activation function will have to, so depending on the inputs, so the neuron may get fired or may not get fired. So it depends on the input, the bias, and also the activation. Okay. So to put it in a simple terms, so this neuron is just a linear combination of the inputs. So what is the Z here? Z is nothing but equal to, we have this B plus B into x naught, which is just 1, plus W1 into x1 plus W2 into x2, and so on and so forth up to Wn into x. So one of the components of this neuron is just a linear combination of, right? All of you have studied the linear algebra, right? So what is the linear combination? Linear combination is nothing but even these the vector of inputs x1 to xn multiplied by the vectors and take the sum. So that is the linear combination. So then after this, now we apply some activation function and then we get the output. So here this F is the activation. So given a neural network, it is a very good function of processing. What it means is that if you have a data wherein the output depends on the input, right? And there is some relationship between the output and the input, right? So this neural network, well, not a single neuron, but the multi-layered neural network that we talked about in a few minutes. It's very good in capturing that relationship that exists between the input and output. But if you look at that, the major part is all linear combinations, right? So what if there is some nonlinearity or nonlinear dependence between x and y, between the input and output? So that is where this activation function is very, very important. So this activation function is the one that helps us in capturing the nonlinearity that is in the nonlinearity of the dependence of the data and the output. So this is very important. So this is a brief historical overview. So actually, the very first model of this neuron started in 1943 by Nicolet and Pitts, followed by Rosenblatt, right, and followed by sort of A. Minter for a decade or so, and then because of Hinton made this back-propagation algorithm very famous. He was not the one who first applied back-propagation. Many scientists before him had applied it, but sort of he applied it to neural networks and make it work. So that's what Hinton and his team did. Who is Hinton? Who is Jeffrey Hinton? Have you heard about him? He won some big award last week. He won the Nobel Prize for physics science because he worked in the physics software. Along with him, John Hopfield also, who worked in the field of neural networks, physics of neural networks. So, along with him, John Hopfield and Jeffrey Hinton, they both got Nobel Prize for physics, and especially the work that they have done in machine learning applied in physics. So where does Hinton work? So you have to know a little bit about history about all the famous scientists that have done this. He's actually was a faculty in University of Toronto in Canada, and for some time, maybe more than a decade, he worked with Google Drive or Brain also. So it's part of the deep neural network or the deep learning team in Google Brain. Okay. So he's quite a famous person. And then after that came the CNN, and sort of after that we have transformers like Gen AI, and then so one of the elementary models of this neuron started with McCulloch-Pitts, a neuron model which was in 1940. Right, so almost 80 years ago. So what they did was they came up with this neuron model, which is almost similar to what we see today. We have got inputs, right? And then we multiply the inputs by the weights and take the summation, and then we check the output with the threshold. If it is greater than the threshold, then sort of you get output. If it is less than the threshold, then there is no output, means zero. So this was a very elementary model, and most importantly, here the inputs could only be binary. So here x's could be either 0 or 1. We could not handle real values of the input values. So that was sort of like a breakthrough, because that's how people started modeling the zero. And then next is the Rosenblatt single perceptron model. So here what he did was, there was a slight achievement than compared to the McCulloch-Pitts model. Here the inputs could be any real number. So that's the major change that we have. So again the inputs are being multiplied with weights and then take the summation, and then again compare it with the threshold. Right? If it is greater than some threshold value, then the output will be 1. And if the threshold is less than the threshold value, the output will be 1. So both the McCulloch-Pitts model and the Rosenblatt perceptron model, they are good for only binary functions, because the output is either 0 or 1. But of course at that time that was a great achievement, right? So, but still the restriction was that it can do only a binary class. What is the meaning of binary classification? When you have only 2 classes to be either yes or no kind of. And this is the weight update tool. Of course, at that time, the back propagation of the gradient descent was not used there. So Rosenblatt came up with this weight update rule, right? So where the weights can be updated using this particular formula, and then beta is the learning rate, and y is the actual output, y hat is the predicted output, and x is the output. Okay. So of course, this was the very first elementary sort of algorithm to how to update the. So the idea is, can we do that? So the idea is, so to start with, we will not know what these weights are. So training a neural network is all about finding the values of these weights. So how do we do that? First, we start with some random visualization of the weights, right? So give the input and then compute the output. Of course, the initial output will be sort of like some random. So now we compare that with the actual output, correct? And then whatever is the error, right? So then we try to, based on this error, we try to update the weights. And then we repeat this process until the error is very, very small. Well, of course, there are multiple errors that are available, and simplest one is the mean square error, or in the classification problems, you can use the log likelihood errors, right? Or the entropy errors are also can be used. So this was all good. And another important problem with this model was that, another important problem with this model is that not only this was used to just for do the binary classification, right? And also the data had to be linearly separable. So what is the meaning of this? Data has to be linearly separable. So suppose you have 2 classes of the output values, right? So linearly separable means I should be able to draw a line or a hyperplane and separate the 2 classes. So then we call such data set as linearly separable. But if you have a non-linearly separable data set, then this single perceptron model will not. A simple example is the XOR gate. So what is this XOR gate? Can you write the truth table for this? If you have 2 values A and B, or let us say x1 and x2. So what is x1, x or x2? 0? 0. So if I plot this, how does it look like? So if I take this as x1 and if I take this as x2, right? So if x1 and x2 are 0, then it is 0. So let me represent that with a triangle. Let me represent the zeros with a triangle and 1 with a square. And when x1 is 0, x2 is 1, the output is 1. So 1 and represented. And when x1 is 1, x2, sorry, this is x1 group. So in the end, when x1 is 1, or x2 is 1 and x1 is 0, we get a 1, there is also a square. Okay. And then when both x1 and x2 are 1, then we get a, so this is how the data. So basically, so this point is 0, 0, this point is 1, 0, and this is 0, 1, and this is 1. So when both x1 and x2 are same, then we get the output as 0, and here we get this. So now, can I draw a straight line and try to separate the triangles and the squares here? No matter what kind of a straight line I try to draw, right? So there will always be one data point that will be misclassified. Or maybe if you do it first, more than one misclassification. So in 1969, Minsky and Papert proved that the perceptron cannot learn this XOR function. Or in other words, to put it in simple terms, so this single layer perceptron works only when you have a linearly separable, and it does not work for non-linearly separable. So that's where sort of like they hit the roadblock. So yeah, that is that. Sort of like this was the theoretical limitation of the single layer perceptron, and also in the 1970s and 80s, right? So the lack of computational power, right? Overhyped expectations versus reality, and sort of like funding for AI also sort of reduced, right? So all of this sort of led to the first AI later and then sort of in that decade, nothing much. Of course, there was a lot of theoretical work that was going on in the background, so nothing much happened. And so after that, so now let us look at this feed forward and back propagation very, very briefly. So now later on in the later part of the 80s, so people started working on this multi-layer perceptron architecture. So wherein we did not have just one layer, but we had multiple layers. So it's called as the which had the input layer, the hidden layers, and the output. Okay. And now, so sort of we had like multiple ranges and biases, and sort of we can have multiple outputs also. So we can now we can go for multi-class classification also. Okay. So in simple terms, right? So the output at any neuron is given by the weight matrix into the inputs plus the bias, right? And then you use the activation function on that, and then you get the required. So if you have a fully connected neural network, right? So we can go from the first layer to the last layer using this function, and then we can use the backward pass, or also called as the back propagation algorithm to update the page. So in the next slide, we'll see as to. So now these are some of the standard activation functions that we have that are being used. So the first one is the sigmoid function, right? So this is 1 by 1 plus e power minus x, right? So what is the output of this sigmoid function? What does the graph look like? having studied calculus, right? So it's a S-shaped curve, correct? And the output is equal to 0 and 1. What about the span edge?
Another yes.
Another yes, but now it is between -1 to
Plus.
Redo. Redo is basically just the positive part of the input. Okay. And then we have softmax. Softmax is basically used for having the output layer, wherein we need to have the problem. So, yeah, so now here the key area for this back propagation is to calculate the gradients. So how do we calculate the gradients is that, so now, as I said before, we start with the random guess of the rates, or the random initialization of the rates. We give the inputs, we calculate the outputs, right? And then at the output layer, we try to calculate the loss, and then sort of, now we have to go backwards. And that is where in the early 60s and 70s, that's where since the back propagation algorithm was not yet evolved fully, right? So that's where they hurdle. And then now after that, 1986, after the introduction of this backward propagation or back propagation algorithm, right? So we were able to sort of like propagate the loss from the output layer to the first layer. So the next slide. So now these are this is the simple algorithm for both the forward pass and the backward pass. Of course, there is a lot of calculation here, so it can take more than 2 hours just to explain from the back propagation algorithm. To put it in simple terms, so what we do is we calculate the loss at the output layer, right? And then we have to go backwards. So now we have to calculate the loss, or we have to find out what the derivatives are in the last but one layer, and then so on. So now this concept relies on the simple concept from mathematics, which is the chain. So some of the historical papers that you see that, right, they start with this the chain rule as the starting evolvement of the neural. So that chain rule will help us in this backward pass. So definitely as students, when you study this neural network, right, so you should sit down and do this calculations and implement this rather than use the TensorFlow or the Keras, right? So as a first program, try to implement this particular backward propagation. And this backward propagation was developed in the year 1986 by Hinton and his team. Okay. So he was not the one who introduced the back propagation or the gradient descent, but many other people have introduced that. But because of him and his team, sort of it became very popular, and people started using this concept in neural networks. Okay. So yeah, this is that seminal paper by Hinton and his team where they introduced this back propagation algorithm. So whenever the students, when you study this course, probably I would like want you to go through this paper. So this is just a 4-page paper. It's not lengthy, 4-page, but still very very powerful concepts were being introduced over here. So now by using this back propagation algorithm, now we could solve the XOR problem. So what do I mean by solving the XOR problem? So now the neural networks can sort of classify non-linearly separable data. So earlier, the restriction was only for linearly separable. Okay. So and also along with this, there were a few more other problems like this vanishing or exploding the gradients and things like that. And after that, a lot of work has been done. And also during the 80s, again, lack of data set, lack of computing power, right? So it did not pick up very much as we had hoped. And sort of like a major breakthrough came in by introducing this convolutional neural networks. Actually, the first convolutional neural network was developed by a Japanese scientist, I don't remember the name, in 1979. He was studying as to how the cats can visualize images. Right? So based on that, he got that idea and sort of developed the convolutional neural network. And most importantly, this convolutional neural network sort of became famous by late 90s when by the development of this lean-net 5 architecture. Okay. So what is this CNN? Basically, it has got convolutional layers followed by pooling and followed by fully connected networks. So again, when you study the details of this convolutional network, right? So try to implement this lean-net architecture, especially the lean-net 5 architecture. So basically, this was used to the handwritten digit recognition. So there is this very famous data set which is called as the MNIST data set. So this data set is available on the internet and also it's part of the TensorFlow. Also, you can import the data set from the Python program itself. Right? So, what have you guys heard about this data set, MNIST? So, what does it have? So, basically, it has got images of size 28 by 28. Right? I think there are about 60,000 images wherein each image contains a handwritten digit from 0 to. So the main problem was to how can we use these neural networks to identify as to what number is written in that particular image. And this is a labeled data set in the sense for each image the number that is in the image is already. So now the goal here is to train our neural network. And then if you input a newer image, right, which the network has not seen, then it should be able to clearly say as to what that number is. So now this is an example of a multi-class classification because now we have got 10 classes in these, which is from 0 to. Okay. So yeah, in the 90s, this CNN architecture sort of got famous. So these are the constituent parts of the CNN. So we have got convolutional layers. So basically, this is where feature detection happens. And then this pooling layer sort of like reduces the dimensionality of that the outputs of the convolution layer. And then we have the fully connected layer. So wherein the actual classification has happened. Okay. So, of course, again, a little bit later on, I'll show you a program. You can walk through the details of this CNN class, how we can use the CNN to do this classification on the MNIST images. And another major breakthrough came in because of this ImageNet data set, right? So there was this ImageNet, there is this competition that was held in. It started in the year 2011, I think. From 2011 onwards for about even 2010. For about 7 years, there was a competition wherein all the big industries and scientists participated in sort of developing new or sophisticated neural networks which can do, and especially in the year 2012, Intel and his team proposed this AlexNet, which is a type of CNN architecture. Right, which sort of at that time the error was about 26% or something like that, and then because of this AlexNet, the error was reduced to 50%. So that was a great, they did not just win, but they won with a big margin. Of course, now looking back, it looks easy, but at that time it was. So they were the ones first who started to use the GPU acceleration and. The NVIDIA GPUs that they started to use, and they also use the dropout regularization. Okay. So later on, dropout was sort of like more formally explained and sort of like formalized by Srivatsava in 24. So if you want to know more about the dropout, read that particular paper. So especially when you study about these CNNs. So you'll study about the dropout. So to fully understand the dropout, please read that paper, the Srivatsava paper on 24. That is a very good explanation of that dropout. Okay. And sort of like from there, from 2012 onwards, sort of this field of AI sort of exploded because of what were the reasons that it exploded after this? So one important thing was that there is a lot of data available, a lot of digitized data was available because of the advent of computers and smartphones, right? So data collection was done at a very large scale, right? So because of this huge amount of data availability and coupled by another important aspect of the computational power also improved drastically. And both of these things, and now all the algorithms that were developed in the later half of the 20th century, well, they all came in sort of it was a convergence of multiple things that happened in the sort of the second decade of the 21st century. So then that led to the sort of the discriminative network. So sorry, from discriminative to generative. So far, what have we been doing is sort of we are trying to classify different the outputs are based on different classes. So now this led to something else which is called as the generative model, where instead of trying to learn the probability distribution of the output given the input, right? So now the scientists started to think, why not look at just the probability distribution of the output? Why not look at the distribution of the input data? So that's where that led to the concept of this generative models. So yeah, so there is the Bayesian neural networks also now is being used to learn the distribution of the data, right? So that led to this generative models, and so here is a simple architecture that Ian Goodfellow that they developed in 2014. So this is that generative adversarial network, which is a combination of this generator and discriminator model. So basically, if you just give some noise and it could turn up something fake, and the discriminator could check whether it is real or fake, and sort of like this led to your Gen AI. And the major turning point happened in 2014 because of this paper, Attention is All You Need, wherein the Vaswani and the team, especially most of them are from Google Brain, and there's a few people from other universities also. Right, they developed this transformer architecture, so which helped in developing this generative AI, and also which formed the foundation for the large language models. Okay. So of course here I have left out one important aspect here. After CNN to generative AI, there is this concept of RNN, which is recurrent neural networks, which is another important thing. But I did not talk about that. And the RNN also is quite important part over here because that led to the advances in the field of natural language processing. Because of that recurrence in nature, so it sort of helped in predicting the next word in the sentence. And basically your LLMs are also sort of doing that, but it's doing much more than predicting the next word in the sentence. So yeah, I would definitely recommend all the students to read this particular paper and try to understand this transformer architecture, because now all the jobs are in Gen AI, right? If you want to do anything seriously with Gen AI, LLMs, agentic AI, right? So now having a good understanding of the transformer architecture. So of course now after this 2017 then the GPT came in, right? So what is GPT? Generative transformer. So based on that transformer architecture, so now we have all these LLMs, ChatGPT or DeepSeek or the Claude, right? So there are lots of many generative AIs that we have. And now there's another important or a minor aspect here is the prompt engineering. Right? So now how to sort of ask questions to these GPT models so that we get some important or the required. So another concept here that is used here is the reinforcement learning from human feedback. So the way to train these Gen AI or the LLMs is to sort of like we can give feedback to these Gen AI models so that it gets better than Okay. So now let us jump into this simple example. So any questions so far? So next we'll jump into an example. Let us look at a Python program and I'll just briefly take you through this CNN program. So I guess all of you know Python, right? So I've done some predictive modeling, some email regression, logistic regression, evidence and the programs, something with SEO. I guess you've not done anything with more than So here is a simple example of this, how you can use this CNN to do the multi-class classification of this MList. So what does that MList stand for, first of all? So there is this organization called as the NIST, which is the National Institute of Standards. Right? And they developed this data set a long time ago. So especially this concept of handwritten recognition came into picture because of the US Postal Services, right? Where they used to write them. So have you seen any postcards? So if you see somewhere in a museum or something. So usually we write the PIN code given in specific boxes like this. The reason why it was done in that way is that so that it can be scanned by a computer, and then based on the PIN code, we should be able to like sort the incoming letters or parcels, or not parcels, because maybe letters. So that's what the US Postal Service has started, and this National Institute of Standards started working on this problem. So they created this data set wherein they had the images of all the handwritten digits. And then now when you scan it in a computer, you should be able to understand what those digits are. That's where that problem actually originated from. Okay. So and M stands for modified because the initial data set was a little bit crude, and they modified and sort of like cleaned up that data set. Because that's not the whatever the image that you see today, it's not what it is, right? So there was a lot of cleaning up and labeling and many other things being done. So that's why it's called as the MNIST data set. Okay. So now, so this MNIST data set has got 60,000 images belonging to the 10 different classes. Okay. So the 10 different classes of the digits are from 0 to. So now first we'll look at as to how we can import this libraries and the data set.
The actual implementation?
Yes, yes. So we need to use NumPy, random module, Keras module, right? And actually in Keras dataset itself, MNIST is there, so you can load it from there, or you can download the MNIST data from Kaggle or any other websites that are available. So if you download it, then it will be in the form of a CSV file. So you might be thinking as to how can we store images in a CSV file? Can we store images in a CSV file? How? How can we store images in a CSV file? Images. Or how are images stored in computers? Forget about CSV. How are images stored in or how are images? What? JPG formats, PNG. But what are those things basically? Let us go to the very basic of PNG and all those things are some different formats of saving the same image. Whether it's PNG or JPG, how is it stored in a hard drive? Pixels. Pixels means resolution. So basically they are nothing but numbers. So when I say that each image in this MS data set has got 28 pixel by 28 pixel, so it's basically a matrix which is of size 28 by 20, and the numbers inside represents the value of that particular pixel. Okay, so the value ranges from 0 to 254. So I don't remember exactly. One represents black and one represents white. What is it, sir? 0 is?
0 is black.
0 is black. 255 is white. So depending upon that number, right? So you have this intensity. So then, yeah, we have all these 28 by 28 numbers. So 28 by 28, I think is 764 or something. So each image is nothing but can be class 764 numbers. So if you actually download, rather than using this the built-in data set, I would suggest to download that CSV file and look at it. So if you look at any one particular row, you will have a bunch of numbers with 764 columns, and we leave one more column for the label. And that extra column is the label, wherein it says what that image actually is. That it's the digit from 0 to 20. So you can download this data set or import it from Kira's data set, right? And then we have to use various other modules, something like sequential, dense, dropout pattern, and also convolutional 2D and max pooling 2D metrics. Okay. So now we can load the data set something by using something like ms.load underscore data. If you're not using this, probably then you'll have to load the data from a CSV file. How do you load the data from a CSV file into a Python program? So there are multiple ways, but what is the standard way that we do it?
It's a relative part of the it's the relative part of the CSV.
So what modules will you use? We generally use standards. So we use standards and then load that. So here also, so now what we have to do is after loading this, we have to divide this into the train and the test, right? So what is the meaning of this? So let me explain this particular part. What is the meaning of this training and testing? What is happening during training and what is happening during testing? Any idea? So what we do is, now we come up with a neural network architecture, right? So now the main thing is here is that we need to figure out what the weights are in this event. So how do we find the values? So initially we do not know the weights. So what we do is we assume some random values for the weights. And then we start giving the input. So we'll give the first input and compute the output. Of course, for the first time, it will be something large. Right? So then we compare it with the actual output. Right? We compute the error, then do the back propagation, and by doing the back propagation, now what we have to do is we have to update the image. And then you have to go through this entire data set, right? Multiple number of times. Then you can do it in batches, or you can do the entire thing, right? So there are various other concepts also, right? And then you can go through this entire data set multiple number of times. That is the POCs. Okay. So then by doing this repetition several number of times, so now sort of like we get the appropriate weights, wherein such that for any given input, the output sort of closely matches with the actual. And this process is called as training. So now to train this neural network, we need some data set. So now in the given entire data set, we will not take the entire data set for training. What we will do is we will split it up. So maybe something like 70% of the data is used for training, and maybe 15% for testing, and there's another concept like validation and so on. So those are all the details that you will be learning slowly. So we need to do that splitting of this training and testing. So now, so actually I think there are 60,000 for the training data set itself, and I have taken 10,000 for the test data set. Okay. So next is this data preparation. Okay. So if you look at this, the way this data is loaded as in this particular form. Okay. So it has got, I think out of this, I've just taken only 20,000 just to save some time. So it will be of this form. So we have to do some data cleaning or data reshaping in the case over here. Okay, so we'll do that also. And then another important thing that you have to do in any machine learning is the rescaling or normalization. Okay. So in this case, now the pixel values are varying from 0 to 225. Now we can make it to be between 0 to 1. Okay. And there are various normalization techniques. Okay. So you can do the standard scaling, there's min-max scaling. Okay. So there are various methods that are available. So especially this part is quite important, especially when we are working with numerical data rather than image data, right? So especially suppose let us say that you are trying to get a simple linear regression model, right? Where you have the size of the house, right? The number of bedrooms, how old is the house. So now in this case we have multiple features, and the range of these features might be huge because the size of the house might vary from something like a few hundred square feet to thousands of square feet. There are a number of bedrooms in like maybe 1 to 5 or something. So in that case, there is a huge difference in scale between those two. So in that case, it's better to bring all the features or all the features basis to the same or at least similar. So that is one of the important aspects that you have to. So and then after doing this scaling and everything, so this is how you do the, first we have to do the reshaping. Okay. And then, yeah. And then also we have to change these classes to sort of like categorical. So that's next. So now, and this is where the sort of we are doing that scale. So we are dividing each and every pixel by 2. So now we come to the actual part of this building this model. So now, well, what should be the neural network architecture? Well, that's sort of like a big question. So here I've just considered the 2 convolutional layers having 32 and 64 filters. Okay. So what is the meaning of this filters? So now suppose I've got this image which is of size 28 by 28. So now what I will do is I'll take a filter, let us say for example of size 3 by 3. So then filter means basically again these will be some numbers. So now what I will do is I'll take this filter and which is a 3 by 3 and then sort of like I'll slide it over this, slide it over in the sense. Now I'll place this 3 by 3 over the first 3 by 3 part of this image. Then how the convolution is done is just simply multiply the 2 numbers and take the summation. So that is the basic idea of the convolution. So that's why this is called as the convolutional neural. And then what I will do is I'll start sliding this filter one by one or maybe multiple steps. So again there is a step of slide and all those things, right? So you can do that and then sort of like move from left to right and then from top to bottom so that we cover this entire. So now by using this convolutional layer, so what is happening is the inner workings of this convolutional layer is that it is trying to extract some features in the image. So especially suppose let us say that we are working with an image set where we are going to classify the given image based on whether it is a cat or a dog, right? So especially in these convolutional layers, what is happening is that so it's trying to extract certain features that are distinctive between cat and dog. So for this, there is a very good video that you can watch. There is this YouTube channel called as 3 Blue 1 Brown. Have you watched it? Have you seen this? 3 Blue 1 Brown. So there they have explained this, how this convolution is happening and what is happening the output of each of these convolution layers. So this is a very good channel wherein they do a lot of visualizations related to neural networks, machine learning, even math, right? Linear algebra also, right? So this is a very good channel that you should be following. Regularly they will be posting videos, so please do follow that. That gives you sort of like a very good understanding of the. So that is what the convolution layer is all about, right? And then after that we followed with this max pooling layer and followed by the flattened, and then we have the dense layer, or also called the fully connected network. So basically what is happening here is that in the convolutional layer we are extracting the features, and then in the fully connected layers, sort of that is where the classification is. So here is a simple way to create this neural network architecture, right? So we start with this model is equal to sequential, and then sort of we can keep on adding the different layers. So now I have added this convolutional 2D, which has got 32 filters, and the size of each filter is 3 byte. So now what are the weights of these? So now what should be the numbers that go into this filter? That is our weights. So that becomes our weight, and that is what we need to sort of train this network. Then we have got convolutional, two convolutional layers followed by max pooling, followed by dense. So this is the overview of the neural network architecture, right? So convolutional 2D, so we have got 32 filters. So these numbers here give you the number of parameters. So for after the convolution 2D, we have got max pooling, then we have got dropout, then flatten, dense, and dropout, and then finally, in the last layer, the number of neurons is 10. This is important. And how many neurons are there in the input? It is 26, I think it should be 28, right? It should be, I think, 28 by the way, because the input is 28 by the way. And so by doing this, the number of parameters here are 1.2 million approximately. So with this just very simple example of CNN itself, right? So we need is 1.2 million parameters. And then we have to train those 1.2 parameters. So this is just the description of that. So now, how do we train this? So there is this, first we have to compile this model, then we have to specify all the different parameters that we are going to use. So now we are going to use the categorical cross-entropy loss, right? And we are going to use the delta algorithm here. More than that, there's another famous algorithm, the gradient descent. Also for the neural networks, we use the stochastic gradient descent. Actually, that is a very famous algorithm. Again, this other delta is a modification of the gradient, the same gradient descent algorithm. Okay. So have you studied the gradient descent algorithm? Yes. Probably in your optimization course. Definitely in the all of you studied gradient circles. What is the gradient? Gradient is nothing but the vector of all the particles. And the idea is that when you're trying to minimize the loss and you're starting with some initial text, then you have to go in the direction of the gradient. So that is where it's sort of like the rate of change of function is minimum. Actually, the negative of the gradient is minimum, positive will give you the maximum data. So that is the basic concept. So to have a good understanding of all these neural networks, mathematics is very much important. You need to know your linear algebra, your calculus, and most importantly, probability and probability distribution. So these three are sort of very fundamental things. So after mentioning this, and the metrics we'll be using accuracy as the metric. Okay, and then now we'll fit the model. How do we fit the model? Now to fit the model, we'll use the training data set, and then sort of we have mentioned something about the batch size and the records. So let me talk about this batch size. So now we have got 60,000 images in the trainings. So now what we can do is we can use the entire 60,000 images and try to update the weights. But that will take a lot of computation. So instead of going through the entire 60,000, what we do, we go in batches. And I don't remember what we did. Usually we keep that like 32 or 64. So and then what that means is that each iteration we take 32 copies input and then we update these dates, and then we take next 32, and so on and so on, and then we complete the entire. And then this epoch says that after going through this entire data set, so we go through it again and repeatedly. So that is part of the epoch. So to execute this program, you can see that initially the accuracy is about the training accuracy is about 85%, and sort of like as we go through the iterations, finally the accuracy is about 99.1%. And then now once the model has been trained, now we can evaluate this model on the test data. So we can evaluate it using the X test. So the test accuracy happens to be something like 98.5. So now here we saw this concept of this dropout. Why do we need to use this concept of dropout? So as with any machine learning algorithm, there is this concept called as overfitting. What is this overfitting? Area. So overfitting is one sort of like the neural network or any algorithm sort of memorizes the training data. And then when you actually test it on the new data, then the accuracy drops. So overfitting is how to identify or how to catch this overfitting is that plot the training error versus the test or the validation. If the training error is very, very small or the training accuracy is very high, whereas the validation loss is quite high and validation accuracy is low. So that's when we know that the overfitting. So how do we address this overfitting? One concept is using the concept of regularization. And dropout is one of the methods of regularization, and that is sort of popular in neural networks. For the linear regression, we have other type of regularization, income regularization, but in the neural network, mostly dropout is used. So that is a very important concept. So that you should always check your training error or the training accuracy versus the validation. So you have to see that both of them are behaving similarly. Okay. So now we have found out the loss, and I think that's all it is. Any other questions? So now another extension of this neural network that I am working is on physics. Physics informed neural networks. Now I use neural networks to solve differential equations. So that's another thing, and there are many other applications of neural networks. Any questions? So are you guys taking up any online course apart from your study here? See, now we are already in fifth semester, right? We are in third year. It's not too far away. So now I don't know, have we incorporated Gen AI courses?
Yeah,
Final year. So don't wait until the final year also, because actually the placements start happening at the beginning of the final year, right? So now is a good time to start learning about Gen AI, LLMs, what is this agentic AI? So now that's where the placements are happening. So should always be on your feet and learn to implement the fields that are. And since I was talking about history, well, I don't know, now many things are happening, but we have to wait and see which one catches up. I don't know whether AI will explode again much further. We don't know. We have to just wait and thank you, and thanks to all the time.
Thank you for the wonderful session and sharing your insights on neural networks. I hope you all learned a lot today. Yeah. So I request Dr. Ramaiah sir to kindly hand over the mic to the next speaker. Please give a round of applause. Thank you.
of feel like I'm back at home.
So you were telling about the courses. Could you please, you were telling about the courses. Could you please tell our students like what type of courses will be helpful for them?
Yeah, currently I'm also taking one course on agentic AI on Coursera by IBM. So yeah, there are a lot of concepts around this agentic AI because now that's what most of the companies are working on, developing a sort of a personal assistant or multiple personal assistants. So there is this concept of brand also, people augmentation and generation, which sort of tries to reduce that hallucination. So there is a pattern. The course that I'm going to is that IBM AI with So it's good to take up such courses, right? So that when you go for interviews, probably the educators would want to know more about the current technology. Start taking some of those courses. Prompt engineering is another thing that is which is sort of required. So there is this website which is called as I think promptingguide.com. So that's got very good resources on this prompt engineering. I would suggest you to take some course which has got some kind of assessment. Otherwise, you're just watching videos and then sort of go or unless you are not fully disciplined, right? So implement the courses. So don't just restrict yourself to the prompt engineering. Try to do something with Python programming, right? So take up a pre-trained LLM, right? And train it to your own specific needs, right? So there is this concept of transfer learning, so which can be used for CNN and various things out there. So make use of those. I don't know whether it's available for transfer learning. These LLMs. Because they are commercial source.
APIs are
APIs are So yes, take those online courses, especially at the end of the semester, right? You have some time until the next semester starts, so you can go back to time. Or even take it up now also. Where are the new semesters? Is it the middle?
Yes. First semester.
First semester. So at the beginning, right? You can start taking because learning takes time. It's not like you take some course and you learn like the whole thing. Oh, thank you. Thank you all for the.
Tea and refreshments are arranged outside. We shall take now. Simple is done by
What you're doing is really clear. That's what it is. One way is 1.5 plus again. That one takes 1.5. Direct bus takes 5. I'm said only 1% whoever attends properly and should ask because it's nice. But only travel purpose is near schedule, not the one that covers the receiving one location and then
Next session will start in by Vallar. It is on its way. Around 45 April. We will have some PM start by
I'll see you.
What feedback can anyone give? Given the validation. This how you felt and what you want to follow. Anyone of one student share their thoughts. You can prepare, it will be around 3, I think, validated will be around 3:50 method. You still have time to get prepared for this. Anyone of you interested? Anyone of you interested to check this is the feedback about the 3-day workshop. You can cover all the if I call it whatever you said, Have you registered for the workshop?
I was just asking if the campus managers given enough
I mean, yeah, once at least we are getting it. Eight percent. I'm sorry. I need to do this. I need to do It's coming First, I just make you get
I asked one social media is fractured. Here is one question. He has a big fracture. He said Anand he will send one more lab instructor, but nobody came. You can inform your friends.
Also, I didn't have this. I don't want to like at least in the morning do this. Okay,
What's going on? How the plan?
So Dana, so good morning everyone, welcome back to our next session. So today we have with us Dr. For this session, we have Dr. Kanta Rao Bhimala. He is a senior principal scientist at CSIR Fort Paladin Institute, Bangalore. Let me just introduce him to you. So, Dr. Kanta Rao Bhimala is a distinguished scientist with impressive career in CSIR Fort PI, where he currently serves as the principal scientist. His academic journey includes MSc in meteorology from Andhra University and a PhD in physics from Bangalore University. With over 18 years of research experience, Dr. Rao has contributed extensively to atmospheric modeling, computational physics, and data-driven simulations. He has worked with ISRO, CSIR, NIO, and CSIR 4PI, and has published papers in various reputed international and national journals. I extend my warm welcome to Dr. Kanta Rao to today's session. I request Dr. Jyoti AP to welcome him with a floral bouquet. Thank you, ma'am. So, sir will be delivering a session on statistical methods, the backbone of big data, scientific research and development. So, over to you.
It's audible? Voice? Yeah. Very good afternoon, all of you. We are going to be afternoon only. My session is almost morning. So, first of all, I would like to thank the organizers for this workshop, for giving me the opportunity to share some of my knowledge with the young students kind of thing. Okay. So, then it is, whenever I saw the invitation like that, this is very relevant topic, right? Recently, statistics in data science and machine learning. So I thought, okay, I will share some of my research experience and because our laboratory now, whatever I am working, it is a CSIR, Fourth Federal Institute. Okay, earlier our institute name is Center for Mathematical Modeling and Computer Simulation, that is CMAX. So now, the government of India, they have thought like that, okay, now the era was changed, now people are moving to big data, then machine learning, deep learning kind of thing. So there is a dedicated kind of, institute is required. So they have renamed our institute like that, they call it a national laboratory. They renamed like the Fourth Federal Institute. Okay, so it will basically, our institute will focus on this kind of AML activities for the whole CSI. So, today, just I would like to share some of the things, whatever I started my career almost in 2005 to 6 kind of thing, almost 20 years. So till now we have done, the research shape was changed. Okay, last 20 years it was changed very dramatically. So whenever we have started our research is different, whatever now we are doing, right? In future it may change in a different manner. So whenever I will go through my slides, then we will discuss more, because whenever we will see the workshop and conference, the reference is like that. The workshop is very easy because we can one-to-one interact and we can see, okay, whatever the thoughts we have there, we can share, then we can learn more things. Conference is very easy, whatever I will tell you and I will go. Okay, so this is one good thing like that. Your people, they have organized a workshop, that is we can interact with each other. We will see how this kind of machine learning and deep learning, it will be useful for our daily life or research life or whatever industrial life, we will see. So just before starting my lecture, just I would like to introduce my parent organization, okay? CSIR, how many people will aware of CSIR? I believe. People are aware of CSIR? So CSIR is a Council of Scientific and Industrial Research. So it is a premier laboratory in India. It is normally founded before the independence, 1942 kind of thing. So we have a cluster of very premier institutes, almost 39 research laboratories are there, all over India. You see, you name any very big research laboratories, that is a CSIR cluster only. In Bangalore, we have two laboratories. That is, one is National Aerospace Laboratory. That is NAL, we will call. That is mostly people are working on aerospace and aerodynamics kind of thing. Then our laboratory is there. That is CSR 4th Padel Institute. So basically, we will dealing with the earth science related works. Then we are dealing with AML kind of related. So, like that, if you go in any part of the country, you see NCL, National Chemical Laboratory, that is Pune, one of the premier laboratories. That is the CSR cluster. And if you go to Hyderabad, we have CCMB. Whenever the COVID was came, that CCMB, they have a lot of research and vaccination kind of thing. So, this is also part of the CSR kind of thing. So, because why I am telling you, there are so many premier institutes, so they are working individually, but they are in the CSR cluster. Okay, we will call that, that's why now one CSR kind of concept came. So people will understand like that we are working on different streams. If you see aeronautics, then genomics, oceanography, whatever, everything, most of the multidisciplinary kind of things, so CSR is progressing. Okay, our people will work on engineering streams, science streams, okay, so many various streams our people are working. So this is just some kind of brief introduction about our CSR. Okay, can you go for next slide? So this is some kind of glimpse I am giving. So Honorable Prime Minister, he is our president. Actually, for our CSR, he is the president. So whatever the governing body, steering committee, he will be the steering committee member like president. He will be. So Honorable State of Science and Technology, he is our kind of vice president. So she is Kaleshwari, Dr. Kaleshwari, the project director general of our institute. CSR. So here I am showing this is our laboratory. He is now presently the director of our institute. So he is director of publication Bhaskar. So basically he is pioneering cryptography, AML, machine learning. So now he is leading, okay, to way forward our institute to the mostly AML and data learning kind of. So now presently, you can look for this. So presently our institute normally we are already focusing on two mission mode projects. Okay, that is one is like one project is like agri technologies. That means whatever the nowadays the recent agri technologies are there, then we are trying to advance with the recent kind of drone technologies. Okay, then the recent IoT technology. How we can inbuild in a farm level kind of thing. That kind of one premier mission mode project is going on. Then one more kind of thing project is going on. That is basically like a computing kind of thing. So we are, our people are trying to adjust so much. They want to develop a lot of algorithms. So that is for the deep learning and this machine learning kind of thing. Okay, because our institute, it is recently, it is one of the best supercomputer we have. So almost it is having 3 petabytes kind of thing. We have lot of GPU cards. Okay, so it is capable of doing whatever the state of the art recently, whatever the computations we can able to do. We have a lot of computing, cloud storage kind of thing. So this system, it is completely open for the CSR whole laboratories. Like if anybody want to do any kind of expensive computation simulations, they will come and they will work in our HPC kind of. So recently only we have recruited almost more than 30 scientists. So they are basically, the interesting thing is they are basically from the AML background kind of thing. So earlier we are working in earth science kind of thing. So now we have dedicatedly we have recruited for the people who is working AML in different fields. That is like healthcare, agriculture, earth science, different like that. So this is basically I am the meteorologist. Okay, we will work on atmospheric sciences. We will work on climate change related studies. Like that we will work on. So how this climate change will impact on different streams. So that is our major job actually. So then it will come like why this climate change people is required now deep learning kind of thing, suppose. Why this climate change and science people want to learn the machine learning. See right now we are in a domain like that. I cannot tell like that, okay, I am a meteorologist or I am a physicist, I can work on only some silos kind of thing. Now it is the era like that, interdisciplinary. So we have to combine with all these statistical people, physics people, then we are going for the machine learning, means whatever the computer science people. So together people are trying to build the systems which is sophisticated and which is the state of art kind of thing. So like that, nowadays the science is going. So this is now, just I would like to study earth science as a natural laboratory. So if you see here there are a lot of processes. Okay, I think you can able to understand. This is the daily routine kind of thing. What it is hampering us, natural disaster kind of thing. So whenever you will see now rainy season. So major news is like that. What is there? There is a cloud burst in Himalayan region, or there is a landsliding. Okay. So the majority of the news it will cover whenever it will come the monsoon season. So it is mostly like cloud burst. So this cloud burst is a recent kind of thing. Earlier nobody will talking about this cloud burst. Okay, because now the climate whatever it changes. So nowadays these cloud burst events are increasing more. Okay, in different challenging regions. That is like Himalayan region, the Western Ghat regions. So people are more focused like that. Why this kind of cloud burst is happening? Okay, what is the main physics behind this cloud burst kind of thing? So we have to understand basically based on observations or based on the modeling studies, or we have to go for now intensive kind of data analysis kind of thing. So just I would like to tell the simple thing is like that. So since so many decades people are working on research. Okay, we have started 20 years, 30 years before people are working, right? So now we are telling like a big data science. Earlier we are doing that is the research. That is the traditional kind of research. Now we are going towards like that some big data kind of, right? So what is the difference? What is the difference between traditional kind of thing and what is the big data kind of research? Have you understood anything? But what will be the difference? So suppose just I will tell you one simple thing. Earlier, can you go for next one? I will come back again. Little bit further. Little bit. Next. Yeah, here. So, earlier 20 years before when I started my career, there we have a research questions. Okay, we have to understand how the temperature profiles are varying in the Ramaiah. Okay, so temperature profile means it is not like your surface kind of temperatures. We have to go a little bit deep, that is almost 1 kilometer deep. We have to understand how the temperature is varying in the oceans. That is our research question. We have to understand because that will have a lot of impact on weather, climate, monsoon, there are other systems. So we have a research question. What we have to understand the temperature profiles in Ramaiah, right? The question is very easy, very simple, like we want to understand. But here the problem is data. Okay, this data it is very tough to get because it is very expensive kind of thing. So because we have to take one vessel kind of thing, and we have to travel, then we have to plan the experiments. Based on that one, in all weather conditions, we have to go and we have to dig some probes, different locations. Then it will give the vertical profile, the temperature. Okay, so that is like 20 years, 30 years before kind of thing. People, because we have very simple question in laboratories, we will come and discuss like this. Okay, we would like to study what is the temperature profiles in the Ramaiah. Question is very easy, but whenever we will go to the realistic kind of thing to collect the data, so here the challenges are there more. That means whatever data we are gathering, it is more expensive kind of thing. Okay, so that means we have to go to Chennai, then we will plan. Because ocean is a very big thing, right? From here to Andaman to their family itself it is a, actually we will in Indian Ocean, this is a very small portion. Then we have Arabian Sea, then we will go to the equatorial region. So it is completely like that in Indian Ocean kind of thing. If you want to study, we need I think plenty of course of we have to spend to understand how the temperature profiles are there, right? Then it is a very difficult task for us because we don't have that many resources. We don't have one probe cost is almost that time I tell it 20 years before it is something like that, some 50,000 rupees or something like that. One probe. It will go, it won't come back. Because that probe is attached to one small kind of oil. We are in the ship, almost here. We are here almost somewhere. then we will drop the ocean, whatever the probe is there, the vessel is moving, then we have to drop. Then that wire will unroll, then it will go to almost 1000 meters kind of depth, then it will give what is the temperature profile. So that is the profile, whatever one profile we are generating, it is like that we have to spend so much of money, so much of effort, so much of manpower, we will go and then we have to see. So everywhere we cannot put right, so we have to divide, we have to plan like that, okay. So where angle, suppose if I want to understand the temperature profiles, how I will deploy my probes, right? And what we will divide. The things is like that different, okay, 1 degree by 1 degree kind of thing we will see. So whenever we will locate the marks like that, okay, here from one location will come, then we will start our experiments, we will drop things. That means total experiment we will put some 10 to 15 probes kind of thing on one sector, then again we will move to some other sector, we will put some 5 to 15 kind of thing. Because it is very expensive data, we cannot put everywhere something like that, okay, data points, all the probes we cannot put, okay. So then now the data will come to the laboratories. Then our team, research team, we have to understand like okay, the profiles, whatever it is coming, whether it is correct or not. That we will call data curation kind of thing, right? Whether this profiles, whatever we are getting, whether this is correct data is or not, we have to check secondly. Then we have to construct like that the temperature profiles in different locations to understand the whole Bay-of-Bengal the temperature structure. Okay, so here the statistics will play a role, right? Because we have very few observations, but I want to understand like how the temperature is varying the whole Bengal. Okay, maybe correct or it may not be correct, whatever the data is available, we have to see some statistical tools to understand, okay, this is the whole Bengal, the temperature structure is good. So, in earlier research is like that, the question is very easy because I want to study. But the data, whatever we are collecting, is very, very expensive. Okay. So like that, each and every month our teams, one team by one team, it will go, they will go and collect the data. So like that, some 30 years of kind of thing, we have some, now we will try to understand, okay, this season, this kind of temperature profiles will be there. Some other season, this kind of temperature profiles is there. So it is like a very, very tedious kind of job. But it will give you a very good information. Okay. So this is something like what I am telling you. What is the difference between the big data science, whatever we are talking about, and earlier kind of research? Earlier, we have the idea, we have research questions, okay? So, we will go accordingly, we will plan our research, then we will collect the data, then we will analyze, then we will try to understand. But now, what happened? Over the 20 years, we have improved our satellite systems, we have improved, there are so many networks are there, it is almost we have built. Then we have modeling systems, we have satellite systems, IoT systems. So now I think we have the plenty of data. Okay, all over Bengal, all of Indian Ocean kind of India, whatever we have plenty of data. Now the research question is like that, we have plenty of data, then you understand what is this data is going to be telling. Now it is different, almost ulta kind of thing. Now what is happening? We have the data, but we don't know what the data is telling. Earlier is like that, we have the research question, okay, but we don't have data. But now we have lots of data, but we don't have research questions. Because now people are hiring the people, okay, now you study this vast data, now you understand what data is trying to tell you. Now you identify what research questions you are trying to address. Right? So this is now the, so whenever we are going some 20-30 years, the way of research is almost changing. Okay? So now data is very cheap. Right? Wherever available data is available. But from the data, if you want to get some feature, something like that is very costly. The research questions are very costly nowadays. Nowadays, we want to understand what this data is trying to tell. So that's why now data analytics, these people are more demand, right? Whenever you see normally, people are nowadays, earlier, I don't know, there is a post called something data analytics kind of thing, or data engineering kind of thing. Nobody is, I think, there. But now, more demand is for only this big data research, big data science. People are trying to understand, okay, because we have that data is there, then how to construct the data in a meaningful manner to understand some research kind of questions, right? So that is the basic difference between what is the new kind of data science we are trying to do. Earlier what the research is going on. So we cannot compare like which is better or which is wrong. Okay, because whatever the availability is there that time we are doing, but now what is availability is there, now people are trying to understand that. So now, now we have plenty of data is there. Then we have to understand some methodologies how to purify this data, because suppose if you take internet kind of thing nowadays we see the big data is coming now, business is running most of these businesses are running with all this data only, right? So suppose if I will go and search, now I want to purchase some mobile, just I am searching. Then after some time if I will open my Amazon or some Flipkart, immediately you will get like this iPhone is there, this is suitable for your search. Something this MI is there, this is suitable for. So like that, whenever we are trying to search itself, the data engines are like that. It will try to go and pick something suitable kind of for you. It will come and give you. Okay, right? So now the business models are like that. So anything you put, then immediately it will try to understand the requirement. So then it will come and tell you the suitable kind of thing. So now the era is going to be like that, right? Can you go? So stop it. So now this is something. Just I want to show like that. What is the current population of the globe? You see, almost they are here now. 8 billion kind of thing, global population. Okay. Now, there is a probability like that, it will go almost 10 billion by very recently. Okay. 2050 kind of thing, we will almost touch to the 10 billion kind of thing, right? So now, 10 billion people, earlier whatever we are almost like that here, you see here. The population it is rising from here, like that 1800th century kind of thing. It is very exponential kind of growth, right? So now we have more demand, right? Because we need more agricultural products, we need more industries, we need so many things. Okay, because the population is growing exponentially. So what we are trying to do? We are trying to put there are a lot of industries. Okay. Then now, because of these, because nowadays if you see the life expectancy also is increasing. Almost earlier in India, I think it may be some 50 or something like that. But now it is almost, it is gone to the 70 plus kind of thing. Then if you go to the some developed countries, it is almost 80 plus. Okay. So it is not like that. One way the population is going on, then life expectancy because of all these facilities, it is almost increasing. Right? So we have more burden. And suppose whatever the resources are there, it is not increasing, right? So we are trying to increase our industries, we are trying to increase our population, we are trying to change our land, right? That is land cover. So that is the biggest thing. Now Bangalore, why this much of kind of crowded means because we have converted all this agricultural land to the residential areas, right? Almost. And then wherever if you go to the village, whatever the forest lands are there, that we are converting to the agricultural lands, right? So it is something like that. The land is whatever the which is land cover that you will tell. In your technology, it is changing. Okay, so whatever the forest it is converting to the agricultural lands, whatever the agricultural lands here it is converting to the residential lands, whatever the residential lands earlier now it is coming to the more commercial kind of things, industries, that kind of things are coming, right? So whenever this kind of mass population is going on, obviously what will happen now? Global warming. People are talking about global warming, right? That means what happening? The carbon dioxide levels, whatever it is there, that is rising almost, right? Can you go back? So here if you see, this is the carbon dioxide kind of thing. They will measure in monolova observations. You see, from the 1960 onwards, how rapidly it was gone, CO2. Almost it is 320 kind of ppm to almost 420 now. Okay. But it is very simple, the numbers will show very simple carbon dioxide, but this is a global kind of numbers, right? So, whenever these carbon dioxide levels are increasing, what will happen? Normally, these we will call as the greenhouse gases, normally. This is one of the major greenhouse gases. Because what it will do, it will increase the atmospheric, heat retention capabilities. That means, whatever the outgoing whatever radiation is going from the earth, it will capture, mostly. Don't allow to dissipate in the space. So because of this CO2 kind of thing, what will happen? Our normally the lower, whatever we are telling mixed layer kind of thing, this is trying to be increasing the heat. Okay. So whenever this kind of global, whatever you tell India like that, the heat is increasing, then atmospheric water holding capacity will increase normally. So that's why what is happening whenever you will see earlier days, our farmers they never bothered about the rainy days kind of thing because earlier days it is very smooth kind of rainfall. You 120 days in monsoon, very nicely distributed rainfall is there, right? Because they never see this much of extremes because whenever they want the rainfall will be coming in that kind of ratios only, well distributed kind of thing. But now because we have changed the atmospheric structure like that, now the rainfalls are happening like that. Whether it will happen like that, it is downpouring in 1 or 2 days kind of thing, right? Nowadays we see everywhere that is happening in Bangalore and wherever you go, the rainy days are going down, but the intensity, whatever rainfall it is coming, it is not going down. Simply like that, earlier suppose it is 100 days of rain, now we are getting in some 50 days, some 40 days kind of thing. So because that is the first criteria. Second thing is like that, this kind of mass rainfall is happening in a very short period kind of thing. Like Bangalore kind of thing, wherever it is there, we don't have percolation capacity like here. Wherever we are seeing all roads, networks, everything like that. Normally water won't go. So very intensive rainfall, 10 centimeter kind of rainfall is happening 1 hour, 2 hours. Then we don't have that kind of drainage mechanisms to dissipate this kind of water, right? So because of that, whenever small rainfall will happen, Bangalore will start almost most of the places traffic jam kind of thing. There is no other solution for that. So the solution is like that we have to do nowcasting. That means whatever suppose 2 hours before something we have to tell like that. Okay, in your area now it is going to be rain. Then you alert. That means now the forecasting system earlier days. So suppose 48 hours before or 1 week before. Suppose we can able to tell like that. Okay, now this 1 week some rainfall will happen. Now it won't work because now we want to tell like a nowcasting 2 hours before we have to tell. Okay, this area is going to be rain. Then only our systems will alert, right? So that means whenever we are trying to do the nowcasting, that means that we don't have much time to compute, right? Because 2 hours before if I have to do, I have to start my simulation something like that. My computation power should be very strong, like that. Suppose earlier my simulations are going to be suppose some 7 hours or 8 hours kind of thing. Now it's got to come down to 1 hour, 2 hours kind of thing, right? Then second thing is like that. Observation, whatever observation network is there now over Bangalore, the data should have to come to our central point. Immediately there should be a system to create the data, then the data should have to go into the modeling part, then model will outputs will give something like that, okay, something is realistic. Understood now? So now it is a very complex mechanisms are involved now. Because earlier the scenarios are different, now the scenarios are different, demands are different. Okay? So that's why we have to develop now AI systems. Now people are talking about now AI systems and engineering, right? So that means we have to develop some network systems kind of thing. Then it will collect the observation data. Then it have to combine with the modeling part, that is physics-based modeling part. Then it have to go for the AI/ML kind of machine learning process. Then whatever the current data is going on, that means now that should have to come to the system. Then everything will have to simulate, then we have to give in a very narrow window kind of thing. Suppose 1 hour, 2 hours, we have to do the forecast. Our demands are like that. So it is not like that simply earlier kind of the physics-based models won't work here nowadays. So that's why each and every sector we are trying to move to develop the AI systems, to upgrade the system, right? So this is some kind of example. If you see, now global temperatures are increasing almost 1 degree, and now people are telling it will go for 1.5 degree kind of thing. Okay, so this 1 degree, 1.5 degree, it is very easy to understand. Okay, what is there in the day-to-day kind of thing? Okay, we have diurnal temperature, we have water variation, right? Morning Bangalore is something like a peculiar. Morning temperatures are different, afternoon is different, evening is different, almost. Okay, it is the dynamic range is very huge here. But these whatever temperatures we are talking about is a global temperature. This 1 degree is it is like that something very important. 1.5 degree if it will cross, I think almost so many islands it will vanish. Almost nowadays if you go, my father's yes. One more. Here. Now this slide why I am telling here, you see here, the CO2 is increasing, right? Then here, because of the rainfalls are increasing. Then what is the problem? If you go to the oceans, if you see here, the evaporation is anyway it is increasing. So the CAs, the carbon oxygen levels, so these are all going down almost. Suppose if you go here CIS, it is reducing almost, ice sheets are reducing. And because of all these things, the sea level is rising. So if you go, we are evidencing in India itself. If you go to the Kerala kind of coast, there are so many places it is going to be raised. All these almost people are planning almost like that, right? So it is a complete system. That's what we are telling. It is a natural laboratory. Okay. Somewhere some problem is there. It won't end there because it will have compound impact on each and every system, right? So if you want to develop a system, this kind of complicated system, if you want to model or something like that, so it is very difficult because these are all the physical processes. We have to try to understand the things. Then only we can able to see. Suppose somewhere some problem is there, then how it is relating to the rainfall. Suppose somewhere problem is there evaporation, how it is increasing to rainfall. So there are a lot of combinations are required to understand what is the interrelation between these parameters, right? So then only we can able to build any system. So we have to understand these interrelations. So that's why people are coming to the now again old statistics people come. People will think like okay, earlier anything is there, suppose we want to correlate any two parameters, simply correlation is there, right? People will tell like okay, whether these two parameters are correlated well, that means these two parameters are very well understood. Okay, it will decrease, then it is the same thing. It is decrease, something it is not decrease. But it is not simply something like that, right? So these correlations, it will misguide us. Sometimes what will happen? It will nicely, the correlation will come around 0.9, but there is no relation between these two parameters, right? Then because we have to understand whether really this physics, whatever the one parameter physics is really impacting on the other parameter of art. So there it will come like that physics kind of things. So that's why nowadays, whenever the people are now talking about the machine learning, right? Whenever this machine learning or deep learning concept came, people are thinking like it is a black box, right? We don't know what is going inside. Only the input data will go, output will come. We don't know what is going in black box, right? Internal, whatever deep learning or machine learning, we don't. People will tell like that, okay, something is happening. It is not a new problem nowadays. Earlier also like that only. Whenever they are trying to see any mathematical modeling, then also some people will write from the decades. They will write so many physics and everything. They will write algorithms to build some model. That model will come to us. Then we will give our input data. They will tell us, okay, you have to like washing machine. They will tell us you have to put powder is here, okay, water is here. Only this system also will know. We don't know what is really going on inside, right? So earlier also people will criticize that is also black box models only. Okay, we are giving input, you are taking output, you are analyzing. Okay, whatever inside it is going on, we don't know, right? Now also same thing. Now if we are developing any machine learning or deep learning also, we don't know really what is going on inside. How the machine is learning, how this deep learning networks are utilizing, that we don't know, right? Now that's why people are trying now physics informed kind of machine learning, physics based machine learning, deep learning. Then like that now people are thinking to try to understand, try to build more informatics kind of thing, physics informed kind of thing. The trend is like that going around, people are developing now, machine learning is done almost now. Now people are now, if you see anybody is there about GPT-5 now, right? Currently GPT-5 is running, right? Recently only it is installed. Now suppose recently some of our students, somebody will come, any question, suppose I will ask, okay, now you go and study rainfall patterns and come back. Next 24 hours my student will come with this much of bundle. Then he will come and show, sir, I have read the verse. Then I surprise you. What? 48 hours, 24 hours is enough. How you have done? Now what is this, sir? I just gone to my GPT, I try to like that, okay, give me the details about the rainfall in India. Then it will give you some 100 pages. This fellow never read that one. Only he will put the input only. Then output will come. Then that output will come and give to the boss. Okay, you read, this is your job now. Simply. Okay. This fellow never understand what is rainfall or what, because it is not like that we don't know. I am asking that children, right? We are asking, but you go and learn, no? You read some paper, so you try to understand some data. Because of that one, you will try to understand the things. But now, it is very simple, sophisticated kind of, we don't have that much time. Simply we have GPT-5. Whatever it will give, we will give. Right? The GPT means what? Can anybody tell? GPT means? Yes. It is like transformer, right? If you properly utilize the transformer, it will give you nice. Like that, pre-trained transformer, generative. Right? That means it will generate. It will generate the things. Suppose if you use 2-3 words, it will generate a nice story to give you. Whether really that was there in the literature or not, nobody knows. Okay, it will give you some story like that. Okay, these 2-3 words are there, it will give you some story to you. But now people are there, they don't have time to verify whatever the story is given by generated by the GPT is correct or wrong. Right? So now people are talking about deep fake. Right? So we don't know what is real or what is fake kind of thing. Now we are in a situation like that. We don't know what is real or what is fake. Right? It is now GPT-5 is very sophisticated. It will create the texts, videos, speech recognitions. Now because there are a lot of advantages, right? Because in earlier days, suppose as I told earlier like that, we have to collect the data, we have to come to the laboratories, we have to identify what is the suitable tools for that one. Then we have to do the graphics for that one. Then finally we will try to interpret like what is this data is telling. But now the AI tools are very sophisticated. Only data is there, that is enough. Then it will try to see what is the patterns are there. It will try to write the algorithms. It will try to do the interpretations. Then finally you will get a very nice graphics like that. Okay, this is your output data. So there are a lot of added advantages of this AI. But we have to use in a very cautious manner, right? So that's why now this workshop, whatever they are trying to target like that, okay, what is the statistics? That means we are trying to understand what this machine learning is doing. Okay, what kind of statistics they are trying to utilize. What is this deep neural networks are replacing, how it is running. So that kind of things, so you should have to understand. That's why in your, I think, engineering curriculum, why they are putting this mathematics like that, because they want to understand what is the basics. Okay, how this mathematics, how these functions are running, all these things they want to understand. That's why in your engineering curriculum kind of thing, they are trying to give all this information like that, physical information, mathematical information, whatever the system you are trying to build in future, it will something like that meaningful way to utilize, right? Can you go for next one? Next. So this is just now I have seen, I have told you like that. Nowadays we have a lot of health problems like that. We have cloud bursts. Then if you come to the heat waves, then one cloud burst will happen, then flooding will happen, then another problems. Then if you go to cyclones, now recently only cyclones are happening. Then so there are so many problems are like that here. Then we have to understand the system. So because the casualty is very high here. You see now 2015 whenever there was a massive heat wave is occurred in Andhra Pradesh kind of thing. Almost 1500 people have passed it. Because if you suppose any forecasting kind of thing, if you can able to tell, okay, this is the temperatures are going and you don't come out for this particular period. Because these people don't know, because these heat waves are something like that, immediately people will collapse. These people don't know what is going to be happening for him. Because the heat, the transfer, whatever it is happening, it is very quick and rapid. Like when a half an hour or 15 minutes, it suddenly it will rise. Then that kind of time period, whoever the people are there, then they will collapse immediately. Even though you are very young or old, that doesn't matter kind of thing. Okay? So the system is like that kind of thing. So, can you go for this one? So this is in 4PA recently, I think some of the work we are trying to do. This is like that because of global warming and climate change. So nowadays this vector form, because whenever the monsoon season will come, what is the biggest problem for us? Viral fever, right? Dengue, malaria, chikungunya, I think These are the major things. Okay, whenever rainfall will come, Bengaluru kind of thing. So this is the major thing. There are a lot of outbreaks. Okay, dengue outbreak is there in Bengaluru. Okay, so how we can predict? Now, sir is telling you they are trying to build up the healthcare systems, A and healthcare system, right? So now, how to understand and how to know when these outbreaks are happening? That is the biggest question, right? Suppose if you know when this outbreak is happening, then we have the preventive measures. Like that you can go and sanitize and you can reduce that. There are a lot of other mechanisms are there. But the major question is how, whether there is an outbreak is happening or where it will happen and when it will happen. These are the questions we have to try to understand the before like that. We have to try the models, we have to understand. Then only we can able to tell like that, okay, our healthcare system, you will just go on to do this kind of spraying like that, these areas are vulnerable. Then they will react. Okay. So then only we can, because now recently the COVID, whenever the COVID came, I think can you go for next one? Recently when this COVID came, why I am telling you, how this machine learning, what we are trying, deep learning kind of thing, how will it will influence in our day-to-day kind of research. And the COVID came, go for next. Next. I think you were the last. So what is happening? I will tell you. When the COVID was happening, right? So the cases are increasing rapidly, right? Everywhere. But earlier, whatever diseases are there, at least we know what kind of virus it is, how it will behave with the atmosphere, how it will behave with the humans. So many information we have, right? But whenever this kind of new virus came, we don't know the behaviors of this virus pattern. We don't know the behavior, how it will react with the atmosphere. So there are so many unknown questions we have, right? Then we want to develop a physics-based model for this one. Suppose if I am to predict the COVID cases, right? So it is very difficult for the people to using the physics-based model because we don't know the physics, right? So that kind of cases, so this machine learning or deep learning will work very nicely because you have the data. What it will do, it will try to understand the patterns of the data. Then it will try to create some model, right? Then it will give something like that. Okay, now the data is telling like that. So the disease pattern may go like this, or the disease pattern may go like this. So this kind of unknown kind of things, whenever the COVID kind of some unknown patterns are going on, then our deep learning, machine learning will play a very crucial role. Okay, to understand these patterns, right? Because we don't have anything. We don't know how this disease will end up or when disease will transfer. Okay, because one state will increase, one state will decrease. But we don't know how the temperature is impacting, how the humidity is impacting. So there are so many unknown things that we have to see. Okay? Can you go for next one? So earlier we are trying to see whenever I am starting my thing, we are trying to observation in the ocean kind of thing, right? Then the satellite era came. Okay. So in 2009 kind of thing, I was working in a space application center of Ahmedabad. So that is a satellite era almost. Okay. So here nowadays we have two types of satellites, right? You know, two types of satellites are there. Anybody? That is one is geostationary kind of thing, then polar orbiting, right? Geostationary means it will look into one particular place. Okay, then it will observe what is happening in India. Okay, suppose some cyclone is passing, it will observe continuously some often kind of thing, then it will understand how this cyclone is moving, right? So that kind of systems, if you want to understand, we need geostationary kind of. Then if you are coming to the polar orbiting, because it is like that if I want to know whole globe, okay, very high resolution kind of thing, then this polar orbiting satellites will be there. It is like low height kind of altitude kind of thing. Then it will rotate polar like that. When the Earth is moving, then it will also rotate. Then if suppose some one way kind of thing, it is almost it will cover whole globe. Okay, so it will give what is the information, whatever the crucial, it is targeted kind of information of whole globe, right? So that kind of information it is done. That means now the data packet it is increased, right? Almost whatever earlier observations are very small. Our Excels are enough for that one. But now, whenever it is coming to the satellite era, it is giving the complete global, right? the frequency is increased, whatever the data points are increased, right? The resolution is almost nowadays we are getting in meters level. Almost the cartosat or something like that nowadays it is giving almost meter level. Earlier it is like 100 meters or 50 meters, 1 point is getting. But now almost we are getting in the farm level. Suppose if I want to study the agriculture kind of thing, we can able to see at least farm level kind of thing, how the soil moisture is varying in the farm level. At least the technology is developed like that. Okay, we are going to see very high resolution kind of thing. That's why now Google Maps are refined like that, right? Almost the meters levels we have accuracy. So whenever these kind of mass systems are happening, so here also one more problem, retrieval, because it is not like that simply the satellites will measure the soil moisture, right? What it will have? It is having only radiation. Whatever the radiation is coming from the satellite or whatever it is coming from the ground, it will absorb the radiation. Then we have retrieval algorithms for that one. Then we will try to see how this radiation, whatever the crucial bands are there, is related to particular parameter. So that day we are calling about the retrieval algorithms. So we are trying to develop some retrieval algorithms for the rainfall or the humidity profile. So whatever the brightness temperatures are, what we will call whatever the temperatures we are measuring, from that one we are trying to see the temperature profiles or whatever it is. So there also the data intensity is increased, right? So now observation to the we are moving to the more intensive satellite data. Then now after that one, the era came like that mathematical modeling. Okay, this is now people are telling about the third paradigm kind of thing. Okay, mathematical model means then whatever observation is available, then we have mathematical system. Then we are trying to build the mathematics in that one. Then whatever observation is available, we are trying to simulate the things. Then we are seeing like that how okay now projections are there based on the physics based model, right? And it will try to understand the independence or dependency from the two parameters kind of thing. Then it will try to project kind of thing. Okay, these climate models are very expensive kind of thing because it will involve in so many parameters, almost 100, more than 100 kind of parameters, right? It is not like a 1 or 2 parameters kind of thing. Okay, so then the mathematical models came evolved, right? So mathematical models also the same thing like that. Observation is required, then we have to try to modeling, then algorithms, and finally we are getting outputs, right? Then now models also whatever physics based models it is the people are thinking like it is not sufficient. Earlier I told you that so right because now we want nowcasting kind of thing. Okay, so now people are going to be the data science almost because now data science is like that we have plenty of data is available. Whether we can bypass these physics based models, okay, then we can build data driven tools. Okay, suppose if I want to predict the temperature for the whole India, what we will take some 100 years or data temperature profile to take. Then people are trying to train the models, right? Whenever you are training the model, you will try to build some equation, okay, because it will pick up some crucial parameters or crucial patterns kind of thing, then it will build some equation kind of thing. Then that model will predict the next feature kind of thing. Okay. Now that we are telling about the data driven kind of thing. Okay, what are the predictions they are telling? But the problem is here the data, right? Whenever we are talking about the data driven models, so how this data is accurate, then what kind of features we have to pick up from the whatever the data available, right? So that way we will whenever we are talking about the data, the feature engineering, right? The people will talk like that. Whenever data is coming, why we need because we need to understand what is the crucial parameters here I have to pick up, right? Now whenever we are talking about the LSTM system nowadays, long and short term memory, right? Now people are lot of people are replacing for the time series analysis. Okay. So what it will do? It is simply like that 3-gate system, right? There is an input gate, target gate, output gate, right? Simply it is like that means whatever the data, massive data you are giving, it will just split like that 78-30 kind of thing or 80-20 kind of thing data. Then 80% you will try, 20% it will give for the validation purpose, right? Are you following you? Okay. So that means what is happening whenever I am giving some time series data, the target gate it will see like that. Okay, whatever the useless things I don't remember that one.
That means it is forgetting. Whatever the crucial features are there, that only it will try to understand. Then based on that one, it will build a model and it will give the forecast, right? So it is like that. What that model, LSTM model is trying to do, whatever the time series data, whatever the because nowadays the time series data is coming like that 15 seconds, minutes. Okay, the data volume is very high because this kind of because of the IoT system is giving nowadays that the whatever sensors, whatever we are developing, it will give that kind of high resolution, high volume data. But each and every bit of data may not be useful for you. Okay, suppose if you want to try to build kind of thing, it may not be useful for you. Okay, but why we need frequency bit? Some episodes will come, some second or some 1 minute, something will happen. How to pick up that one? That's why this high resolution, high frequency kind of data, it is playing a big role in this machine learning. So here, then we are trying to see that okay, we have big volume of data, and people are trying to see. Suppose if you know this all story like that, if you know the parameter, okay. So now if you don't know the things, now there is some supervised learning, unsupervised learning. There are so many things like machine learning kind of thing. So what they will do? Now people are spending a lot of money to supervise, right? The thing. Suppose if I will use this image, this room image, then they have to understand who is wearing the specs or who is what color the curtains are there, what kind of shirts are there. So each and everything you have to label it, right? That labeling is more costly nowadays almost, I think. Earlier days people are spending more time for this labeling only. Because we don't know the data. Okay, whatever one picture if I will give, I don't know what is that picture, how the model will train. Okay. So earlier this is the major problem, like labeling the data. Whatever the image I am giving, whatever. So then now it is like that unsupervised kind of thing. Supervised is very easy because we have labeled data. Is there, then it is easy, it will learn and it will give the prediction, right? So like that now it is going on. Can you go further? So this is just because this is something of work we are trying to do here. Okay. So something like monster vegetation dynamics. Okay, all over India. Suppose if I want to see the vegetation dynamics, that means how this vegetation is varying. Okay. Because now earlier on I told like that. Now we have a lot of land is land coverage right? Because we are converting the agricultural lands to the residential lands, like that, residential to commercial lands, then forest to agricultural lands. Then suppose earlier it may be a paddy field, now we are converting to some other field kind of thing. Earlier it may be a mango field, you are converting to some other things. So there are a lot of variations are happening, right? So how? Suppose if I want to see in a whole India level, if I want to understand how we will know. Okay. So because of that one, now there is a satellite data is available for that one. Okay. Actually. So we have some 20 years of data I have taken. Then how to do that one? Because 20 years of data is there, I have to understand like that which part of the country is changing in what class of land is land coverage changing, right? So here there are so many features are there. So because multi-dimensionality is there, right? Suppose I have different years of data is there, right? I have different classes of land use because some class will tell okay this is like urban area. Some class will tell like that okay this is like croplands. Some class will define like okay this is like some broadleaf areas, forest. So all these things I have to classify and I have to understand like that okay which part of the country. Suppose vegetation is increasing or decreasing. Suppose it is increasing means why? What is the reason? If it is decreasing means what is the reason? There are so many other things I have to do, right? So here we are utilizing like principal component analysis. Like this is very old method. Now whenever you are trying to see any kind of data machine learning kind of most of the things people will use this one only, principal component analysis, right? Because what it will do, it will reduce the dimensionality. Suppose if I have 20 years, 30 years, 40 years of data, if I want to see in one single shot what is happening, so I have to use this one, right? So we will utilize the PC analysis kind of thing. So we will try to understand, okay, some parts of the country it is now vegetation is growing. Then we will tell that what is why. Suppose Rajasthan now if I will tell okay there is some vegetation is going on, and people will ask question right why. Then we have to tell like okay whether there is irrigation is going on. Earlier there may not be irrigation kind of facilities or any borewells they are digging. Okay, that kind of data again it will come. Then we have to try to understand like that. Okay, because of all these water resources are there, then they are going for the more farming lands, right? Then only we can able to tell this is like reversal because I have the data. Then I understand whether some parts of the India it is going to be vegetation or some parts of India it is going to be okay dry regions. Then we have to go and collect some other data like whether there is any rainfall is increasing or there is any crop patterns are increasing or demand is increasing. Now all these features suppose if I want to come, I need some system like so very sophisticated. I cannot do. I can only tell okay this is happening. But now because if I want all this kind of data, now the network is required. So that's why now the data intensive kind of research is playing a key role here. Okay, because I want to understand the things very properly. So I need more data. So I need more data. I have to understand the data in a proper manner. Otherwise, it is because I have a lot of data. I don't know how to understand the data, right? So now we have vast kind of data. Then the picture is coming that how from the data, vast kind of data, how I will extract the pictures which is required for me, which is required to understand my physics, right? So here it is coming like the data science. Okay, what we are calling about data science, meaning like that, like it will come like that. This kind of scenario. It is not like that simply data science means okay, some input data is there, I am giving you something and it is coming something output. It is not very simple kind of that much easy is because the data science the meaning is like this one because we want to understand multiple interdisciplinary systems. Because now suppose I am a physics fellow, I cannot tell I don't want to learn any statistics because I need to understand the things. Because suppose if I want to understand what is the social environmental, I want to understand what is the geography, I want to understand how the oceans are behaving, I want to understand how the temperature is going on, I want to understand how the disease models are acting. So these are the as a scientist we have to understand all these parameters in a single shot, right? But we are humans, right? We cannot understand this many things at a glance. That's why we are building the artificial intelligence kind of thing. So the machines can learn. Humans may not. That's why we are trying to understand we are feeding all these things to the machine. Okay, you learn and you behave like a human, intelligent. Okay, because one human cannot do, because we need some network of people, right? So this kind of massive data, if I want to understand, it's very difficult for us. So we are building the artificial intelligence systems. So it will try to understand the GPT means why, because whenever whatever question is asking, it is telling me. So the GPT is trained for all kind of varieties of data, right? How many parameters GPT-5 it is using, you know? Almost, I think some 100 billion kind of thing, parameters. Okay, trillions kind of thing. So that means if any human being, if suppose I want to understand some 10 parameter itself, my life is going good. How can I understand this kind of billions, trillions of parameters are? That's why here the importance of, because we were telling right, okay, A will come, then there are so many disasters will come, but this kind of systems is important for these kind of problems. Wherever the humans, we cannot able to understand the things very properly because of massive data, because we don't have understanding of so many varieties of disciplines. So we are trying the one model kind of thing. Okay, you learn so many things. Then the domain will sit. It's not like that. On some cancer kind of, suppose some cancer images are there, I am training. Then it is not like that model can build and it will tell the features. But finally the doctor should have to sit to understand, okay, whatever the feature is coming, okay, the data, the model is giving, is correct. Something, some domain expert should be there. It's not like, that's why now people are talking about the domain people should be there, then the computer people should be there, then systems people should be there. Everybody combined, they are trying to build these kind of massive systems. Right? That's why like that they are progressing. Because now the workshop is belonging to this one. Why machine learning is required? Why the deep learnings are required? So there are a lot of differences, right? Machine learning and deep learning, right? Are you aware? Huh? There are so, because nowadays people are talking about so many buzzwords, right? Generative, AI, agent. There are, I think plenty of words. I think Now I am also reading so many things, so I think now this so many terminology is coming, we don't know what is the difference, really. Because it will, because that kind of features, that kind of algorithms people are developing, okay, so we really we have to understand so many things, we have to learn so many things, okay, to understand the things. Yeah, have time, madam?
Yes,
Huh?
sir.
Is it boring or can I stop? Huh? Okay, can you go first? Next, this is also one question. So this is some interesting work recently we have done, okay, in Bangalore itself. Okay, because now we are trying to tell like that, okay, where rainfall is happening. Okay, now biggest question is like that. People will tell, I need the exact location, right? People will tell, I need exact location where it will happen. Second question is like that, how much rainfall will happen, right? That is second question I want. First question is like where it will happen. Second question is how much it will happen. But this is very chaotic system. Atmospheric systems are very chaotic, right? Chaotic in the sense like that. The model will behave in a very chaotic manner. Suppose one initial condition I am giving, what is the output is coming. Suppose one equation is there, right? X I am giving, Y it is fixed, right? But these chaotic systems are like that. X if I will little bit I will change, Y will come differently. Y something else will come. Okay, that means this kind of atmospheric chaotic system, this is non-linear system, what we will call. Whenever we are trying to address about the non-linear kind of systems, you should be very careful because whatever the input data you are giving, a small modification if I will do, by whatever the solution, everything it will dramatically will change. I think there is no output, first we have output to second output, there is no relation at all. Because that kind of chaotic systems we are working on. So, here the question is like that people, outside people, we can easily tell like, okay, Bangalore you tell where is the, because then first of all we have to understand how the Bangalore pattern, because we don't know the data. First of all, how the Bangalore road networks are there, how many buildings are there, how many floors are there, okay, where is the commercial areas, where is the agricultural land, so because the Bangalore is growing like rapidly, suppose tomorrow if I will go to Whitefield now, it will show like that it is something like that, some US or something like that. Earlier it is completely forest areas. Marathali, I think our NL is and people are telling 20 years before. After that, Marathali is completely jungle. Okay, but now Marathali is something like very commercial. I think you cannot enter almost. Suppose my that's why Bangalore traffic speed is how much? 4 km, 5 km per hour. Almost. Suppose crucial places. My office is there 45 kilometers only. My office is here, I will go somewhere another office. From there to here I will take every day 1 hour kind of thing. 5 kilometers only. Almost 1 hour traffic. So these kind of situations we are there nowadays. So if we suppose these kind of chaos, we don't know the data patterns, how many households are there, how the data is going on, what is the pollution ranges. So there are so many parameters it will involve in physics systems. So then finally our question is when it will happen, where it will happen, you tell me exactly. Then that is the very biggest expensive question for us. Okay? Then we will try to build a model. Then we are using the observation because Karnataka government is one of the sophisticated government. Okay, almost 6,000 plus rain gauge stations are there. All over Karnataka, nowhere in India it is there. Karnataka is such a very so role model for all the states. Okay, they have very good network of all this observation network. So in Bangalore itself we have 100 stations, almost 100 rain gauge stations in Bangalore. So at least we can able to understand where the rainfall maximum is happening. Suppose I have 10 years of data, I can understand. Okay, how the rainfall characteristics are there in whole Bangalore at least, right? Otherwise earlier I know only one rain gauge or two rain gauges will be there, one is in HL, one is in somewhere else. Then how I will understand how the Bangalore rainfall characteristics, because one station is in HL, some station is some Chikkulabara. Then I cannot understand, right? We will give a daily one observation and tell you, okay, today this much of rainfall is happening. If somebody is putting some water somewhere, one bucket of water, that is also it will measure. Okay, that is rainfall only. Okay. So earlier the observation mechanisms are like that, but now we have a sophisticated mechanism. This is all telemetry kind of thing. Okay, the data whenever it it will happen rainfall, then immediately it will go to the their system. They will know how much rainfall is happening, where it is happening, okay? Then we are trying to build a model, then we have seen like that, see, the performance is like that. Whenever suppose this red part is like that, right? This is observation. Suppose here it is yellow part is rainfall is happening, we have to see like that here same amount of rainfall or no. The rainfall, the model is showing somewhere else, right? There was some location error is showing. So that means whatever the observation data, whatever the physics, whatever this combination is not working, because somewhere rainfall is happening, our model is showing somewhere else. There are some uncertainties that we will call uncertainties, right? So we have to handle, because nowadays people are AI also, people are talking about uncertainties, right? Uncertainty aware AI. People are talking nowadays the new trend is going on uncertainty aware AI. So that means whatever AI systems you are trying to build, be aware of the uncertainty in the system, right? Then only it can able to build the whatever the outputs, whatever it is giving, speak something like a realistic. So here we have seen like that. So whatever the physics-based model is like, whatever the observation is there, still the problem is like that. Here heavy amount of rainfall is happening. My model is showing here, right? So there is a location error because we can able to tell how much rainfall will happen, but we cannot able to tell precisely this location will happen, right? So again, then we have to build now the observation system, whatever it is coming realistically, telemetrically. Then immediately the data should have to go into our modeling system. So we have to build the systems, new systems, AI systems kind of thing. Then their observation we have to train. Then physics model we have to utilize. Then whatever the instead of that means currently observations is going on, we have to build. Then we have to build a one AI hybrid kind of model. Then we are trying to see whether that kind of models may give the better accuracy. That is the trend nowadays we are trying to do, right? So this is why people are talking about the big data science. Means what? Big data science means this kind of huge amount of data, realistic times we want us to. Normally people will know earlier people are telling about the data. Data science is common. Earlier also people are collecting the data. Now also people are collecting data. But now we are talking about the data science. The craze is coming to the big data science kind of thing, right? We have to understand, we have to combine the statistics, what are the machine learnings, what is the physics-based model, what is the observation network, everything we are trying to combine one data system. Then we are building the AI systems and engineering something we will create the realistic kind of outputs, right? So that is the now state of the kind of thing. We have to understand the things. Okay, thank you very much. Some insights are there. Okay. Thank you.
Thank you, sir, for enlightening us about the insights on climate change. So you truly reminded us students how important it is the projects, whatever they do, the studies to connect with real world problems. I hope you have got an idea of what climate change is, right? Have you got an idea? Did you know about this before? Alright, it's a very important global issue. Okay, so thank you so much, sir, for sharing your knowledge and time. I request Dr. Gangadhar sir to kindly present the conversation.
Because one more thing that I want to tell you, in institute we have internship programs also. Many students, they want to really work on HPC systems, they want to really connect to the scientists and work. You can, it is like an online system, it is like that. It's no need to go and ask any scientist. It's an online system, you can register. Okay, they will assign you scientist, then you can come and work realistically. Okay, that kind of system in our institute is there. So anybody want, you can explore internships or some 3 months, that kind of thing. If anybody want, you can utilize that one. So almost already, I think more than 1,000 people, I think thousands of people already they took the internships kind of since last 10 years it is doing. Okay, because so many people are aware, that's what I'm telling. If anybody interested, then you can. So you follow something. So thank you very much.
So afternoon we'll start the validity by 3:30. 3 o'clock. 3 o'clock we have validity function. It will already have it was at the assembly, sir. So lunch is at D block, ground floor.
B block. B block.
B block.
Nice one.
After lunch. It was very,
Actually, we want to work with SDG goals, so we take like that. So, wait for us, it was very handy, came across an opportunity. Want to utilize any outside people there.
Those who are arts and workshop, amount some people pay, students they have paid amount also. Because we are not actually students they have like confidence of it. But without very have some special
Actually,
Because the government system-
whatever thing is and we both are
Others,
industry areas, we learn how to code that industry areas. So we want to industry area. The CO2 emission is increasing. That is because of production for so that's why if anything can be done. Start starting only second.
okay.
Same year.
I think can discuss over the table and understand then we will have some meeting. Okay. Then you can come. Nice to meet you.
So very good evening, good afternoon to everyone. Welcome to the validity function of 3-day workshop on statistics in data science and machine learning. So we have come to the end of the 3-day workshop. We hope we all had very fruitful sessions throughout these 3 days and we got to learn a lot of things. So this workshop, we are privileged to have among us today our Dean Sir for the validity function, Dr. Saraj Kumar Maharana. Our Associate Dean Ma'am, Dr. Naina Patil. Today's resource person from CSIR, Dr. Kantara. Dr. Kantara. So, over these 3 days, we have explored a range of fascinating and impactful topics, ranging from probabilistic models, predictive analytics, neural networks, multivariate techniques, big data applications, and today, sir, enlightened about the climate change. Okay, it was very interesting to see how climate change is impacting our Bangalore and all that. Sir has proposed many problem statements which students can work on. So I hope all of you learned a lot of things in today's session. Sir is our principal scientist at CSIR. So I now request our Dean sir to kindly deliver the closing remarks for this event.
For closing remark is short and sweet because you have already spent a good amount of time and learned a lot of things. Your brain is heavy, right? So you will not. Okay, I welcome our sir. Thank you. And it's our honor and pride that he has come all the way from CSLR and spent some time with us and interacted with his campus. I welcome our madam, colleagues and students. This subject is very close to my heart, but unfortunately, though it is close to heart, but I'm far away from this subject now. Except in the darkness, I see. I don't see anything because most of the time in the darkness I'm working on statistics. So hope you like this previous session. And I have a question to test your outcome. Okay, what is the average age here? So simple question I'll ask. How do you compute the average of data set? Any guess average age of this group? Imagine this is a sample, it's a mix of heterogeneous group and stuff.
We'll collect all ages and divide it by
Yes. Yes. Give me a number.
Except for your
Hey, except you tell. Basically learning how much your auto school
maybe 30.
30. Okay. What is the standard deviation of the people who are here? Standard deviation of the sample. Standard deviation. 50.
They're telling 10.
10. Okay. What is the standard deviation? What else? You have more. But okay. What is the average salary of our people here? So anyway, we apply this. We apply the subject. Okay. Good. Then okay. I should know the feedback, but before I request you for the feedback on this, machine learn delivered. You are enjoying ChatGPT. I am enjoying Perplexity. See that Google or something. So what did you enjoy? What you liked the most from the 3-day sessions? Any reply from this? Machine has learned. You learned how machine learns. So what did you learn from this session? And which you can apply immediately from tomorrow, say for example, or from Monday. Can you apply how regression happens? Can you apply the concept of R square? Can you apply how can I reduce the gap between what you have gotten and what you have? You can reduce the gap so that you have the best fit lines very close to your what you are looking for. Can you apply the algorithm? Which one you have discussed?
Today they discussed about CNN.
CNN. Can you apply? Can you take the data set, download from the Python database? You can get some. Many are available. Can you apply CNN for the image file that you take from the from your campus and identify which leaf has a problem or which flower is dying? Can you find it out from CNN? Or which crop is not doing well? Can you find it out using CNN? Or which patient is more serious? So if you have questioned this to yourself, then you have learned it. If you have seen that, okay, our honored guests have come, they have given their knowledge and gone, they will go back to their office. But did you take home these learnings? If you have not taken, if you have not understood, probably it will be very difficult again. ChatGPT will help you to some extent, but not all the time. All the time. Okay. So anyway, thank you so much for giving the valuable time, energy, enthusiasm for this workshop. I congratulate the Department of Mathematics and Computing and Department of Mathematics and Statistics, the coordinators, and the Somasekhar sir, who is on leave today. Yeah, so he's tired, a little bit tired. Okay, and our MCs, thank you so much. I hope that this particular thing will go a long way. If you take 10% of this learning, there is enough for us. Remaining percentage will be added up soon in the upcoming seminars. And we are also very pleased to say that in the recent past, AI activities and implementation has gone little deeper to our curriculum. It is visible, and I also personally thank our resource persons who have taken interest and time out from their busy schedule and have come here, spend time with our students and faculty members. It's a great honor for us, and thank you so much for your presence. The teachers take less stress, but the students take more stress. I'm thinking why they take more stress, because they have got 9 subjects to study. I have got only 1 subject to study. So this is another subject. You also think this as another subject and spend some time, apply in your area wherever you are studying, theory, laboratory, assignments, or your practical life, your startups. And the mathematics teacher, I think sir is not there. I would have told him that next time we are actually planning to go a little deeper into the algorithms at the lower semester level so that you will get that interest. Thank you again, and have a wonderful 1 month. So next December we are coming with a new quantum mathematics. Wonderful. Thank you.
Thank you, sir, for your introduction. I now request Associate Dean Ma'am to just say a few words.
Thank you for the opportunity. First of all, I congratulate both the departments of mathematics and maths and computing for this wonderful initiative. I only, and sir has raised a lot of questions. I think you should learn from all that. And whatever you have learned today, at least some 10 to 15% if you are able to implement in your assignments, in your projects, I think it will be really great. And we also should appreciate the resource persons who have taken a lot of pains to come here and manage the sessions. It's not easy. Moving in Bangalore is not easy. You can easily go to some
He quoted the same in his session also.
Yeah. Really tough job, sir. Thanks for
Our session is like that much time I have.
I know that. That's right. So I hope the students will really come out with some very good projects by applying whatever they have learned here. That will be the outcome of this wonderful initiative. I congratulate the coordinators and others because they have put a lot of efforts in making this happen. And I also heard that a lot of responses have come, nearly 180 have registered. It's a wonderful initiative. Though the department is very small in terms of numbers, it's doing a great job. Congratulations and thank you.
Dr. Anupriya Jha, Assistant Professor, Department of Mathematics and Statistics, to give the event summary.
Thank you, ma'am, for this opportunity. Now, before I summarize this whole event, I need to make 2 points. Okay, for our students.
You can ask feedback.
Yes.
Okay, see, our whole world is like full of stories. Okay, we want to take our story in most perspective manner. Okay, but why? Because stories can sway the people, it can change the perspective, it can change the world. Now, if you apply this thinking, this knowledge you will achieve to some greatness. And we will tell your story again and again to our, who will come again to for their motivation. So do well, whatever you have studied, just apply them and it's it. Now for the event summary, this is on day 1, the session 1 was taken by Dr. R.P. Suresh and it was focused on statistics in data science and its application. Session 2 it was taken by online by Dr. Sudhir Kumar K. Okay. So it was focused on visualization and its best practices. Day 2 was started by Dr. M.T. Gangadhar and the talk is about probabilistic graphical models and its applications. Session 2 it was taken by online by Dr. S.Y. Babu and it was like predictive modeling and how to use it. Session 3 it was taken by Dr. Jyoti Gately and it was all about machine learning and its uses. Session 4 was taken by Dr. Subramanian and it was like statistics, all the basic things, data equations and all that. Day 3 session 1 was taken by Dr. Deepak A.S. and it's all about neural network basics. Session 2 was taken by Dr. Kantara and it was all about deep learning in agriculture. So thank you so much for joining.
I request Zaid Ahmed, student of ISC, to give a feedback on this workshop.
Good afternoon, everyone. I'm Zaid Ahmed from Display System. I'm here to deliver feedback about this 3-day workshop titled as Statistics in Data Science and Machine Learning. Although there's much to say, but I just cited some of the topics that I felt was very interesting and good. Over the past sessions, we had the opportunity to learn about some of the most important foundational statistics in data science and machine learning. We learned the importance of statistics in industry in the era of artificial intelligence, that how data, probability, and statistical thinking drive modern intelligence systems. We also learned the Bayesian and Markov networks, which gave us a great insight how AI models handle uncertainty and perform logical reasoning in real-world situations. Then we came across linear regression, logistic regression, and SVM models, which are the fundamental ML models used for prediction and classification. Also, we learned about the neural networks, how they have advanced from simple perceptrons to deep learning architecture. We also learned the foundations of statistics in real-world applications. At last, we saw something like related to the climate change, cloud bursts, and the application of machine learning and the prediction of these. There are much more topics which have been covered in these periods, which help us gain knowledgeable insights that ignited our minds to think beyond the familiarities. At last, I thank all the faculties and coordinators, HODs, Lead Sir, Associate Dean Ma'am, for organizing such a workshop. Thank you.
Thank you very much. I now request our dignitaries to kindly hand over the momentous to our resource person.
Any other guests who want to talk?
Anyone?
Any external participant, please.
Yeah, we have an external participant.
Ma'am, you can introduce.
Good afternoon all. I'm Mrs. Deepa George from the Department of Commerce from Private University. It was a great opportunity to be a part of this particular program, which is named as Statistics in Data Science and Machine Learning. I have to say that it was 3 days of enrichment, where we had a very good blend from mathematics, statistics, and computer science. Okay, where we also had a blend of in-house expertise and the experts from the industries who gave us lots of insight. So, like, if you see about the way the program, we had 7 dynamics areas in which we have been exploring the past 3 days. It started from graphical modeling to predictive modeling, and it went on to machine learning modeling. And we also saw how statistics is applied in industry. We saw programs of visualization of data, and we also understood how statistics has the logic of statistics and the backbone of statistics in data science. Now, it was a great exposure for me, and there was lots of clarity. Like, to say about the sessions, though I am not a person who is not open to mathematics and machine learning, but the sessions were very enlightening. Starting from like where we understood why we need to have a structural data, like with labeling and search for sayings was a great insight to understand that the data needs to be labeled so that it becomes very structured and we get a better predictive model. And the machine learning session was also enlightening because it was an area which I was not exposed to. And search insight, like though we know big data, but your explanation was beautiful. When someone asks me, like even my students ask me, I now have a clarity to tell what is data science. The clarity that you gave was really beautiful, sir. So I really thank the organizers, the department, both the departments, because it was a great insight. If I have to say statistically, maybe my understanding level from 3 sigma limit has gone to 6 sigma limit. Thank you for that.
Thank you, ma'am, for that wonderful feedback. I now request our dignitaries, our Dean Sir and Associate Dean, to kindly hand over the memento to our heroes.
Yeah, I would like to say two words Okay. First of all, respected Dean and Associate Dean Madam, and all the faculties and students. Okay, good evening, everybody. So this is a wonderful section, the workshop, 3 days workshop. Okay, normally I think 3 days workshop it is normally it is a very great thing, because in our institute itself 3 days to handling the resources it is very difficult. Normally wherever we will go maximum 1 day, 2 days kind of thing, but you have to lot of time and to cover. I think I have seen the curriculum. We have covered almost so many things. Okay, so finally I think this is a great thing. Now the state of the art kind of thing, data science and machine learning. What is the role of mathematics in that one? So it is normally because whenever whatever engineering you study nowadays, suppose we are seeing in our institute, civil engineering person will come, mechanical engineering person will come, and finally they are doing in cloud computing, they are working in machine learning. So there is no limits, something like that wherever you are working in engineering. So finally after completion of your degree kind of thing, where you will work nobody knows actually. So really the computer science people are working machine learning, there is no guarantee actually. So this is like combination of everything. Also it is very great experience, like you will learn like why it is data science, why data science is required, why machine learning is required. So that is a little bit insight. So you will learn here only, because whenever our institute people will come, again we will tell like that we have to learn so many things. So otherwise we have to go for some courses. So now anyway this Ramaiah Institute, they have taken initiative, they understood the importance of this subject. So it is very great experience for me also. Thank you very much.
Thank you, sir. Your sessions were really enlightening.
Yeah, we are welcome. Whatever last some 20 years we are trying to do, so we thought of it will be useful for the people.
So we can come this side. There is a YouTube recording.
Thank you.
I now request Dr. Gangadhar sir, our resource person, to kindly visit the moment. Next, Dr. Jyoti A.P., Associate Professor and Head Program Head Mathematics. She is the organizer as well as the resource person. And next we have Dr. Ramaiah. He is also the organizer as well as the resource person from Department of Mathematics and Statistics.
Camera side person.
I now request all the organizers from Mathematics and Statistics, Dr. Anupriya Jha, to receive the certificate.
We'll take it later.
I request all the organizers, Dr. Manohar, Dr. Akash, if you are here, please join on the dais. And from Department of Computer Science, it's me, Saista Taranam, then Ms. Padma R, Dr. Jyoti Yeti, Pranita, Dr. Madhushri, Ms. Madhushri and Ms. Shilpa. Please join. Mama, sir. Please join. Ma, right from first. Right. Ma'am, you also please join.
Coming friends can.
You able to cover all of us? Touch screen. That's correct. Students can join us. Can you sit here? Sir, we take the photo. All students are here. All students over here. It's okay. This background is there. Just sit here. All of you can sit here. Now you sit. Don't touch it. Touch screen. All of you please sit here.
How much yoga you do at home?
We don't know, but we are making you do it here. Just check what you cover and check. You all of you please come this side also, no? Some chairs can be behind. You can move the chairs behind it, you can sit.
They can stand, there is no problem. They can stand also.
If you want to stand,
Tall ones can go.
Tall ones can be better. Go back.
yes.
Yes.
You can also join.
Okay.
Why are you not coming?
Ready?
Oh, yeah. Don't touch this.
ಸ್ವಲ್ಪ ಮುಂದೆ ಬನ್ನಿ ಎಲ್ಲರೂ.
Ready?
Thank you.
Thank you. Congratulations. Thank you for the support. Thank you everybody.
Ours is the material. Basically, our lab is Okay, our space